Hello, this is Elizabeth from the Academic Support Center at Raritan Valley Community College, and this video is on rational exponents. So this is 10.2 from your textbook, and the rational exponents, in the last lesson we learned about radical expressions, and rational exponents are just another way to write those. So we have we can write a rational expression. We can write a to the 1 over n is really the nth root of a. So let's look at a couple of examples of that. Like if we have 16 to the 1/4, this is the 4th root of 16, or this is equal to 2. We have 49 to the 1/2. We can write this as the square root of 49, or this is equal to 7. Okay, so that's our fractional exponents. When we have a 1 there, we can also have a to the m divided by n, and what this means is this is the nth root of a to the m, or we can write this as the nth root of a and then raise this to the power of m. It's oftentimes easier to, if there is an nth root of a, to calculate this first and then raise it to the power, just if you're doing the calculations without a calculator. So what do we mean by this? A couple of examples we have, or an example, we have 4 to the 2/3. Okay. Oops, sorry. Not what I wanted to do. To the 3/2. So this is we put our fraction out front. So we're taking the square root of 4 and raising this to the 3rd power. So this is 2 to the 3rd, or 8. Okay. And the final thing that we wanted to cover here is that we have, whenever we have a negative exponent, that's really like 1 over. So if we have a to the negative m over n, this is really equal to 1 over a to the m n. Okay, so an example of that might be like 81 to the negative 3/4. So this is equal to 1 over 81 to the 3/4, or 1 over the 4th root of 81 to the 3rd. And the 4th root of 81, the square root of 81 is 9. The 4th root is going to be 3, and 3 cubed is going to be 27. So this becomes 1 over 27. Okay. I have here exponent rules. These aren't all covered in the chapter on the book, so I assume that this is meant to be a review. But when we multiply the same base with different exponents, we add them. When we divide, we subtract. If we have a to the 3rd squared, we're going to multiply those two exponents. When we have a product to a power, we need to raise both of those variables to that power. We have a fraction to the power, we have to do the numerator and the denominator to that power. A to the 0 is anything to the 0 is equal to 1. A to the negative x is 1 over a to the x. And then this is what we covered here today. The fractional exponents can be rewritten as such. Okay. I am going to move this over, and I just have a couple of examples, choosing like one from each section of the assigned homework. So if we want to evaluate 8 to the 1/3, again, we're going to rewrite this as a radical expression, the cubed root of 8, and the cubed root of 8 is 2, because 2 times 2 times 2 is equal to 8. Okay, if we have x to the 1/5, we can rewrite this as the 5th root of x. And likewise, we can go the other way. We can go from a radical expression to a fractional exponent. So if we have something like 1 over the cubed root of x to the 7th, well, our power is still going to be our numerator, but this part is going to be our denominator. Whatever root we're taking, that's going to be our denominator. So of our fractional exponent. So we have 1 over x. The 7 was our power, it remains in a numerator, and the 3, which was our third root, is going to be our denominator. Okay. And let's take a look at evaluating. We have -8 to the 2/3. And me personally, I prefer to take the cube root if it's easier instead of the I usually try and do the radical portion first and then do the exponent. So this becomes the cubed root of -8, and all of this is going to be squared. Well, the cube root of -8 is -2, because -2 times -2 is 4 times -2 gives us -8, and then we want to square this. So this is equal to 4. Okay. And the last one, this kind of shows how sometimes it's easier to convert back and forth. We have the square root of b times the 4th root of b. And if we want to condense this down, it's oftentimes useful to write these as fractional exponents, and then we can use our product rule to add those fractional exponents. So we're going to rewrite these as fractional exponents. The square root of b, so we had a 2 out here, this is going to be 1/2 plus, this is going to be times b, again we have the 4th root, so this is 1/4. That 4 becomes our denominator. Okay, so when we multiply, we add our exponents. So this is b to the 1/2 plus 1/4, which is equal to b, 1/2 is 2/4 plus 1/4, and so this is equal to b to the 3/4. Okay. So that's what I have on these rational exponents. If you have questions, please don't hesitate to reach out to the Academic Support Center. We are here to help.